Okay, so we are going to take a look at the rest of the problems. The example here in red is already done, and this is going to be the sort of walkthrough answer key for the remaining problems. So we're going to start with a question that says, if I use 0.5 moles of sodium chloride dissolved to make 0.05 liters of solution. So remember, this is true for all of these, that molarity, which is capital M, equals moles of solute, that's the stuff that's being dissolved, in liters of solution. Okay, so moles over liters equals molarity. So in this case, they give us, in this case, we're already given moles, 0.5 moles, and we're given liters. So we're given the units that we need, so all we have to do is plug the numbers in and do the math. So the molarity of the solution equals 0.5 moles over 0.05 liters. Okay, that's the units we were given. And 0.5 divided by 0.05 is 10. So this is a 10 molar solution. Now in the Google form I asked you to just enter the number, so you would have just entered 10, not the M for molarity. Second one, slightly different question, 0.5 grams of sodium chloride in 0.05 liters. So the volume, the liters, is the same, but instead of giving us moles, they gave us grams. So this means we have to do an extra step in this particular problem, because we need moles and we don't have moles, but we do have grams, 0.5 grams, and in order to convert from grams to moles, we divide by the molar mass, and this was given to you. You would find this, if you needed it, you would find this by going to the periodic table, looking up sodium and chlorine, adding their two masses together, and it comes out to 58.4. So the first step is converting the grams that you were given to moles, and that comes out to 0.0086 moles. Okay, so 0.5 grams is equal to 0.0086 moles. And we were given the volume in liters, so we just plug that 0.05 liters into the denominator. We do the math out, and it is 0.17 molar. Okay, it was 0.172, but if you round it to decimal places, which I believe is the instructions, you get 0.17 molar. Okay, so moving to the next problem, the number 3 was the example that was done out for you. And actually the result of that example problem, just to sort of show you, is the same because it's 0.5 grams. The trick that they gave you here was they said 50 milliliters. 50 milliliters is equal to 0.05 liters down here. That's one of the steps you had to do in that particular problem. So question number 2 and question number 3 are actually the same question, same problem. It's just that one question gives you the volume in liters and one gave it to you in milliliters, so you had to do a little extra step there on number 3. But you get the same answer both ways. Alright, moving down here to number 4. 734 grams. Okay, so again, we're given grams, not moles. So we're going to have to do that first conversion step of lithium sulfate dissolved to make 2,500 milliliters of solution. Again, it's in milliliters. We need it to be in liters. And just remember that 1,000 milliliters equals 1 liter. So 2,500 milliliters is equal to 2.5 liters. So that's our volume that we're going to use. To get the moles, we need to take the grams we were given, divided by the molar mass. The molar mass of lithium sulfate is 110 grams per mole. Again, that was given to you, but you could look up lithium, and then sulfate is SO4. You could add all that up, and it comes out to 110 grams. So the number of moles is 6.67 moles. Okay, so 737 grams equals 6.67 moles. And we now use the volume that we figured out up here, which is 2.5 liters. So the molarity of that solution is 2.67 molar. And again, you didn't have to include the molar part, but that is the unit. So I want to reinforce that when we look at these answers. But when you're entering it into the Google form, just enter the number. And again, if you need to round to 2 decimal places. Okay, now, this one's actually written slightly different because it uses the scientific notation, but 6.7 times 10 to the negative second is equal to 0.067 grams. Okay, so we're given the mass of this compound, which is called lead acetate. That's actually a very heavy molecule, so because it's got lead and then it's got all these other elements attached on there. So the molar mass of lead acetate is actually 325 grams per mole. So we already have less than 1 gram, and the molar mass is 325 grams. So this is going to be a really small number for moles. And when you do that out, you should get 0.00021 moles of lead acetate. And again, they gave us milliliters, so we divide by 1,000 to convert to liters. So that's 0.0035 liters. Okay, so we got all sorts of decimals and zeros and things. Just need to be real careful when we're doing this math. But 0.00021 divided by 0.0035 gives us a molarity of 0.0035 molar. So very, very low concentration because we had a very small amount of the solute, the lead acetate. Even though it was in a tiny amount of solution, it's still such a small amount that the concentration is very low. All right, so this last question, I'm not gonna write this whole thing out. But if there are 2 solutions, the first solution, you take 1 mole of salt, sodium chloride, and you dissolve it to make 1 liter of solution. The second solution is made by adding a mole of salt to 1 liter of water. Is the molarity the same? The answer here is no. Because, is the molarity the same? No, not quite. Because in the first solution, remember, molarity is moles per liter of solution. So the first one says it's a liter of solution. So when you're done, you've got the salt, you've got the water, the combination of those 2 substances takes up a volume of 1 liter. In the second one, you start with a liter of water, and then you add the salt to it. So the final volume is actually going to be more than a liter because you added something to something that was already a liter of water. So it's not much. 58 grams of salt added to a liter of water isn't going to make the volume dramatically different, but it is different because you're starting at a liter and then adding on to that. So the solution would have a volume greater than 1 liter, which affects the calculation of molarity. Whereas in the first solution, you put the 2 things together and the final volume is exactly 1 liter. So it's a small difference, but that's sort of a classic type of concentration question that you would see. Okay, so the second sheet here is the dilution equation. The first, the formula is up here. The first question is done out for you. All you have to do in these problems is plug in. The trick in some of the questions is just making sure you know which volume and molarity go together on either the left or the right of the equation so that you know what you're solving for. And sometimes it's very obvious which is the starting and which is the final. Sometimes it's not so obvious. And to be honest, mathematically, it doesn't matter if I call, this volume 1 and molarity 1 or volume 1 and molarity 2. As long as I put them together, it doesn't matter which side I start on. So the key thing is really knowing which pieces of data go together. So let's take a look at the first one. We take a 0.15 molar solution. So this one actually, sir, this is a little bit tricky the way it's worded. If I add water, I add water to 100 milliliters. Okay, so the initial volume, so V1 is 100 milliliters to a solution that has a concentration of 0.15 molar. Okay, there. So this is your M1. No, sorry, that's your V1. This is your M1. And the final volume is 150 milliliters. So that's your V2. What is the final concentration? M2. Okay, so we've got our starting volume and concentration. Those two things go together. We put them on the left side because we're saying that that's the starting point. The final volume, right, they tell you this one's the final volume. That's your V2, 150 milliliters. Well, in order to solve this, and we have to find M2, we multiply the 100 times the 0.15, which means we have 1.5, right? And then we divide both sides by 150. So 15 divided by 150 equals 0.1 molar. Okay, and again, on the form you don't have to include the label, just the number. All right. So how much of a 0.05 molar solution can be made by diluting 250 milliliters of a 10 molar solution? Okay, so again, the hardest part, honestly, for these problems is figuring out what is your starting molarity or starting volume and what's your final molarity or final volume. So this is actually our M2, right? This is what we're trying to get to. This is what we're making. By diluting, meaning we're starting with this much of a solution with this concentration. Okay, so the starting concentration is 10 molar. The starting volume is 250 milliliters. And we want to dilute that down to a final concentration of 0.05 molar. And how much volume would that be? Now, just kind of thinking through, sometimes with a lot of these problems you can sort of think through it, especially with something like diluting, right? If you're starting with something that has a concentration of 10 and you want to bring it down to a concentration of 0.05, which is really small, really low concentration, you've got to add a lot of water to it to dilute it down to where it's not concentrated. So the number we get for V2 should, first of all, be bigger than 250, right? Because it's 10 molar at 250 milliliters. In order to get it down to 0.05, way less than 1 concentration, we have to dilute it, make it much, much more volume. So we should get a pretty big number here. So if we have 250 times 10, right, that's 2,500 on this side, and then we actually divide that by 0.05. So since we're dividing a number by a decimal, the number gets bigger. In fact, it gets quite a bit bigger. It ends up at 50,000 milliliters. So you could take that 250 milliliters that you started with of the concentrated stuff, and you could make 50 liters. Right? Think about how big a 2-liter bottle is. Right? So you take 25 of those. That's how much solution you could make starting with that small amount 250 milliliters is, that's I think like about a Coke can full of solution. So you start with a can of Coke, and you can dilute that down to 25 2-liter bottles in volume to get the concentration you want, just to give you some idea of the scale. All right. We have, okay, so that tells you kind of right away, this is our starting point. We have 1.5 molar solution. We have 345 milliliters of it. So there's our starting volume and starting concentration. If I boil the water down to a volume of 250 milliliters, what will the new concentration be? Okay, so this is actually the opposite of diluting it. We're making it more concentrated because by boiling it, we're actually taking out some of the water, but we're leaving behind the salt, right? The salt doesn't boil off, just the water does. So our answer here, the molarity, should be higher than the 1.5 that we started with, because we're making it more concentrated by boiling away some of the water. So when we do that out, right, we do 1.5 times 345, and then we divide it by the 250, we end up with a molarity of 2.07 molar. Okay, so it went up because we took away some of the water, so it became more concentrated. The molarity is higher. All right, and then last one, how much water would I need to add to 500 milliliters of, so this is what we're starting with. We're starting with a 2.4 molar solution. We're starting with 500 milliliters, and we want to make it, we want to dilute it, make it less concentrated, and we want to end up with a 1 molar solution. And we want to know how much water we need to add to do that. So first things first, right? On the right-hand side, we have 1, so that's not going to affect the value at all. So what we can do is we can just look at the left-hand side. 2.4 times 500 is 1,200 milliliters. That's going to be our final volume. The only little catch here is that the question didn't ask what is the final volume. The question asks, how much water do I add? You started with 500. Your final volume is 1,200. So you need to add 700 milliliters. Okay, and again, just the number goes into the Google form. Okay, so if you said 1,200, you did the calculation correctly. It's just that the question was asked in a slightly different way. What it really wanted to know was, if you start with 500, how much do you have to add to get to the right concentration? You're adding 700 because you need the final volume to be 1,200. Okay, so that's it.